Bandwidth for changelog is provided by Fastly. Learn more at fastly.com.
I'm Kavya Joshi, and it's go time.
It's Go Time, a weekly podcast where we discuss interesting topics around the Go programming language, the community, and everything in between. If you currently write Go or aspire to, this is the show for you. All right, everybody, welcome back for another episode of Go Time. It's episode number 42, and today's sponsors are Backtrace and Datadog. On the show today, your hosts are myself, Eric St. Martin. Carlicia Pinto is also on the show. Say hello, Carlicia.
Hi, everybody.
And also, Johnny Borsico is here. Say hello, Johnny.
Hey there. Happy to be back.
And our special guest for today is Kavya Joshi. Now, we should probably start with like an intro. I know you've done a couple of talks and stuff, and you're going to be speaking at GopherCon, but we'd love to hear it from you, kind of who you are, the things you're working on.
Cool. So I currently work at a startup in San Francisco called Samsara. We're an Internet of Things startup. We do hardware, software, firmware, and I'm primarily a backend or a systems developer. And I do a little bit of infrastructure as well. I feel like as of recently, I kind of have a crush in firmware too, so I've been trying to do a little more of that. Apart from my day job, I speak at technical conferences. I've given a couple talks on Go, or Go related at least. I've given a talk on Python, on a Python library. I'll be speaking at GopherCon this year, which I'm super excited about. And I write a little. I just published an article today. In fact, it's my first technical blog post, believe it or not. So I do all of that.
Yeah. So one of the talks that you gave, we'll start there, was Strange Loop, I think, right?
Yep.
Where you did the talk about the implementation of the race detector.
Mm-hmm.
So that was actually really cool. Did you come up with the idea for that, or just like digging into the internals and you're like, hey, I know all about the internals of this. I should go talk about it.
No, I that would have been quite convenient. No, I think the way that talk came to be was I heard about the race detector and I used it and I was like, wow, this is really cool. I wonder how it works. And I have a master's in CS, and as part of my master's, I was in a group that did like distributed systems and operating systems. And so I had a little bit of that academic background to dive into the paper, the thread sanitizer paper behind the Go race detector. And then I read the paper. I was like, wow, that sounds really cool, but I still don't know how it actually works in practice. And then that resulted in me like digging through the source code and playing with the tool in depth. I was like, this would make a really neat talk. And that's how that talk came to be.
No, it's actually really interesting. Like the race detector has been really cool since it came out. I never knew how it worked under the covers and the vector clocks and things like that.
Yeah, I thought it was really cool how something that I'd only like mostly read about in the context of distributed systems was implemented in this tool. The relation is obvious, right? Because you're talking about concurrency, but the translation of ideas was quite cool. I thought it was pretty neat.
So, funny story about the race detector was, I think it was the second GopherCon. One of the speakers, Blake Caldwell, was at the speaker dinner, and he was raving about how awesome the race detector was. And the person next to him, which happened to be Dimitri, turns and was like, thank you. It's just, he didn't realize, and all this hype about the race detector, he was sitting next to the person who wrote it.
Oh, yeah. Yeah, Dimitri's done a lot of cool stuff, huh? Like some of the other tools he's come out with, like GoFuzz seems neat.
Yeah.
All the work on the scheduler, all very interesting.
Yeah, it's hard to follow all the stuff that some of the people on the Go team are doing. It's just so many great contributions.
Yeah.
So that talk, is still super valuable for, I think it was mid last year, or was it the year before that you did that talk at
Uh,
Strange Loop?
that was last Strange Loop, so September 2016.
Yes, it's still very, very relevant for anybody who's interested in how things work under the covers.
hmm yeah, and I think that's my favorite type of talk to give or material to present. It's going beneath the surface. I find that interesting, and I think it adds a lot of value to people's understanding of systems, which is cool.
Yeah, I think I love the idea of learning at least one or two layers below the things you use.
hmm
I think probably from an engineering perspective, a lot of it's because there's a lot of like leaky abstractions.
hmm
So abstractions are great when everything works perfectly, but when things start to go wrong, you kind of want to understand what the thing you're using is doing to help, troubleshoot that.
Yeah,
Plus, it's just super geeky to know how some of this stuff works. Like, why do you know how the
yeah.
scheduler works? You're like, well, you see, I had this odd question one day, and I was like, how does that work?
And it ended up spending like 20 hours on it, but now I can tell you all about it. Yeah.
At least these are things that are useful later.
Yep.
So, Kavya, one of the things I actually found quite interesting in that talk was how you sort of got into the vector clocks and how they're used. That was sort of the first time I'd seen sort of the applicability of vector clocks in that way. I thought basically the illustrations you're using were kind of on point and sort of describing that and sort of making it clear for somebody who has technical background, like how that kind of works. But also, I thought it was approachable, right? So if somebody's a beginner and they're sort of don't quite know how concurrency works, they don't quite know how multi-threaded programs work, that was sort of a good introduction into sort of some of the mechanics that are used in that world. Is that something that you started out wanting to do to sort of make something that's approachable to various skill levels, or this is just the way it made sense in your mind?
That's a good question. I think in terms of the flow, that's how it made sense to me. But while creating the content, I explicitly was trying to make it accessible for people with computer science backgrounds, but not necessarily the knowledge on the topics that I was going to talk about or I was going to have to use to explain how the race detector worked. Um, I think in taking something that's deeply technical and making that approachable and accessible. First of all, it's interesting because it's sort of a challenge, right? It's like I have all this background knowledge, but I'm going to try and explain it to somebody who might not necessarily have that background knowledge. They have knowledge in other areas than other topics, but not necessarily the knowledge that's relevant to what I want to talk about. How do I make it accessible to them? And that's an interesting like communications challenge. And I think the second thing about that is in like presenting a technical ideas in an accessible manner. I think it only results in betterness and like better systems in producing more interesting conversations and sharing knowledge in a way that is accessible. So here's a concrete example, right? Like Julia Evans does a great job of explaining how to use system tools like strace or netcat, and she does a really good job of taking away the barrier to using those tools. Similarly, I have a friend who really likes performance engineering and talks about like profiling and tracing with me and the rest of his friends. And I think in like sharing that knowledge in a way that's accessible to all of us, it results in like better systems being produced, more interesting conversations, like overall like goodness all around.
I really love Julia Evans' drawings.
Yeah. Yeah, those zines are pretty rad. I ended up printing a bunch of them and giving them to my interns. It was great.
I love the point that Kavya is making about presenting technical content in an accessible manner. And I'm thinking here, as Go is growing so fast and people are coming into the language, how do people who are writing technical content and who are writing and giving presentations, how can they do this in a better way? And I'm wondering if you have tips to share with us and with the audience.
Gosh, I wish I had like knowledge that I could speak about in general. I think when I write or when I write a talk, write an article, I spend a lot of time thinking about the presentation of the content, things like what order to present it in, like what diagram, what animation would make it like most intuitive for somebody listening to the talk for the first time. Like what would make it accessible to them.
I think a lot of it comes from our assumptions of what we assume everybody else knows. And
Mhm.
in computer science, especially, more and more people are coming from not without formal educations. So that assumption of having like a formal background in computer science can be difficult. I know there's a lot of concepts that aren't that hard to explain to people that aren't familiar with it. But you open up a book and you're handed a bunch of or a white paper, save yourself. Like looking at the formal proofs, you're just like, okay, maybe I'm not smart enough to understand this. And really, sometimes it's almost like if you start at a new company and you're not familiar with the domain, when everybody's
Mhm.
speaking in acronyms and all kinds of things that you don't already understand, the whole business of what you're building can seem completely confusing and out of reach, right? But once you
Yeah.
start learning the vocabulary and the vernacular, like you start realizing it's not as complex as you thought it was. You're just not aware of all the little pieces and how they come together.
hmm Yeah, and I think that's a great analogy, right? The folks we're talking about, or the folks, your audience, your target audience, they aren't necessarily beginners, or they aren't necessarily people without computer science backgrounds. It's just that they don't have the background knowledge that you do. Because of all the time you've spent prepping prepping for the talk, or just your general interest in the subject, they don't have that background knowledge. So I think it's just being aware of your target audience, like the fact that they just might not have spent as much time geeking out on the subject as you have.
I thought it was a worthwhile question to ask you. This question of like if you have any tips to share about how to prepare content. Because I saw your talk at Strange Loop a long time ago, and it was excellently done.
Thank you.
It really conveyed really well, like Johnny was saying, conveyed really well the concepts of the race detector and things that had to do with it. And for example, for me, one thing that I do, and I'm not claiming I'm even any good at it, but just I go from like, okay, it just, the quality of my writing improved tremendously if I finish and I sleep on it. And
Yeah.
yeah, and if I sleep on it, like the one day it gets better, 2 days gets even better, and then the margin of improvement starts diminishing. But
Yeah.
I think so. Whatever people can do to make the content better, even if it has to wait, I think it's so worthwhile because it will benefit so much more rather than putting something out there that's concise, but not everybody's going to really get it. It's just all these blog posts and
Yeah.
CFP submissions. It all becomes just a lot of noise.
Yeah.
So you were on the track, I think, of saying what it is that you do. If you had more items that you wanted to share, would be great.
Yeah. I guess getting your content reviewed by somebody you trust. So I've worked with a lot of great people, and something like having them read through the article and just tell me if it makes sense as an outsider. So we're very good about getting our code reviewed all the time, right? Like code review systems. So I think if you get your content reviewed, that's helpful.
Makes sense.
One of the sort of recommendations for beginners in Go is to sort of avoid the Go routines and dealing with concurrency primitives, the channels and whatnot. Like don't jump into the deep end sort of right away, because there's a whole different sort of world there that you don't necessarily have to have. For a lot of the programs that you write, it's okay to sort of write them procedurally because you're going to get a major speed bump anyway. Especially if you're coming from something like a Ruby or Python and whatnot. So for somebody who is sort of basically doesn't typically program in a multi-threaded environment, and they need to sort of, okay, I know I've been told not to sort of jump in, but now I feel like I'm ready to jump in, right? I need to know some things, right? I need to have some background for that's going to help me to tackle, a concurrency in Go and do it the right way. What would you say some of that background is? And perhaps you might even have some resources that maybe we could post after the fact in the channel or on the podcast page. But what are some of the resources that you think would be useful for a beginner to go to sort of have? What sort of background would they need to have to really be able to take advantage of concurrency in Go?
I think the Go docs do a great job. There's the walkthrough tutorial, which explains the basic concepts pretty well. But then I think the best way to learn is to read a lot of code and write a lot of code. So there's several open source Go projects. So if you go and walk through the code, probably bust out your favorite debugger, or just write a lot of simple, even if you start with a simple example, to just play around with. What happens if I spawn one Go routine? What happens if I spawn two Go routines? What if I use a channel in this way? What if I use a channel in that way? So basically by getting really hands-on into writing code and reading code.
I'm trying to think who was wrote the Go concurrency visualization tool.
Oh, yes. That's really
super cool to kind of play with and understand kind of how these things are happening in parallel.
Yes. I know the tool you're talking about, but I'm blanking on the author's name as well.
Yeah, there's a recorded GopherCon video, right? Is that what you're thinking about, Eric? There's a recording.
Names escaping me. The number of speakers at the conference are like growing so big. So I mean, it's over 100, I think, in total, right, across all the years. So remembering everybody's name.
Wow.
It's a good problem to have, right?
You're one of the organizers, is that right?
Yes.
Cool. Is organizing GopherCon just insane at this point?
It has its moment. The beginning of the year is usually pretty heavy, and then like the month before the conference is really insane. But it's all worth it to see it come together in the end. But yeah, we're super excited to have you. And the deep dive into concurrency, into channels is going to be really cool. Even I've never looked at how channels are actually implemented. So I think that's going to be really interesting.
Cool. I'm super excited to go to GopherCon this year.
Is that another one of your kind of passion things where you're like, I wonder how that works, and kind of just dive down?
Yes. And especially with channels in Go, they're offered as such a primitive, such a language primitive. And so diving into how they worked was quite fun. And also the fact that they interact with so many parts of the runtime, as you'd expect. It's pretty, I'm excited about the talk.
I'm kind of sad I'll have to wait a month to see. Because usually the conference is so busy, we usually watch everything when the videos come out.
Yeah, that makes sense.
I wanted to ask you about the article you just wrote for Riley. Mm-hmm. I read through it. It's pretty awesome. So at Samsara, where you work, Samsara, is it?
Yeah, that's right.
Do you follow these guidelines? Do you have a set of guidelines?
Trick question.
Do you practice what you preach?
So we follow most of everything in that article. For example, we use the panic wrap library that I talk about to report panics. We wrap all the Go routines that we create in a top level function that does a recover for panic reporting. And we especially find the panic reporting very valuable for our production services. We use an errors package. The package is popular, and for good reason. It's a useful package. We ship application metrics. So that's 3 of 5. What was number 4? Structured logging. We use structured logging. We currently ship our logs to Amazon's AWS's hosted Elasticsearch service, but it's pretty terrible. So we'll probably switch to something like Honeycomb soon. And testing. I wish we did a better job at testing our code, just in general, or having good testing practices. But at a system of our scale, unless you start with like a good testing story from the beginning, it's hard to come in and sort of get that rolling. So we're getting there slowly, but I feel like on the testing side, we could do a better job.
So let me just mention that the article is an article on writer.com, and it's called How to Ship Production Grade Go. Definitely a worthwhile reading. And sorry, I didn't mean to put you or your company on the spot, but when I was reading this, I was thinking it's really cool. How do you go about maybe introducing this at your company if you're already not following these guidelines or any other kind of guidelines for Go development?
Yeah. No, that's a good question. Yeah. What about y'all? Do you have any good tips for other ways to make Go production grade?
Well, I guess a lot of it would be the same for any program in production. Like assume everything dies and that nothing is perfect. You'll get clock drift, you'll get network issues, and those are usually the odd things to track down.
Yeah.
I think this is a good starting point for everybody, though.
I think for a lot of us, sort of using a 12-factor model for configuration of your environment where the application runs is something that has been a sort of a best practice for a while now. I think it's still very applicable, for Go programs, and it's something that we heavily use in our organization. Also, when it comes to sort of designing your applications, right? It's I think what we've seen that has worked consistently well for us, whether it comes to program design or for in turn making testing easier, is to rely heavily on interfaces. So we tend to sort of rely on interfaces over concrete types quite a bit, and then we worry about the implementation details later, because it's much easier to just bring in a concrete type and just satisfy the interface later on. And while you're sort of designing, while you're on a spike and trying to try some things, than it is to sort of rip out those concrete types afterwards. So basically, that approach really of saying, hey, I may not have all the answers right away, but I can play around with some interfaces and help me understand the program a little bit, I think has been really, really great for us, and sort of really architecting our application the way we want it to be.
I love a lot of the stuff that's out nowadays too for just configuration management and secrets management and things too. So that gets more and more important too as you move applications through environments, and prevents people from doing things like submitting credentials to GitHub repos and things like that. That happens a lot.
Yeah.
So like some of these things like Vault and Kubernetes secrets.
Vault is great.
Yeah.
Vault is amazing. Docker also came out with a secret management system.
Oh, interesting.
Oh, yeah?
Yeah. Did I get it wrong? Nobody knows this.
Cool.
I mean, it wouldn't surprise me, because
sure.
it falls in line, with a lot of the container orchestration, like Kubernetes and things like that, manages secrets. So, with them doing their own orchestration things, it makes sense for them to also manage secrets being handed to containers. But I don't think I have seen that.
So I'm not super familiar. I haven't played with Kubernetes myself. We use AWS, so we just run our containers in ECS. But how does Kubernetes do secret management?
Yeah, so there's a resource type that is secrets, and you can manage things. And then basically, there's almost like a manifest file that you use to deploy your containers or pods of containers out. And you can map in those secrets as either a file, so anything running in the container sees it as a file, or as an environment variable. So your program can just assume that a file exists on the hard drive, or that an environment variable exists, and doesn't need to know or care how it gets there, which is really great because QA environment can have its own keys, production can have its own keys. Application doesn't change. And then for testing, even locally, you just set your environment variables and done deal.
Yeah, that sounds useful.
And I just realized we are running late for our first sponsor break. So let's go ahead and take our first sponsor break. Our first sponsor for today is Backtrace.
Software teams use Backtrace to take the headache and guesswork out of debugging across their environments. Backtrace jumps into action when your Go application fails by capturing detailed application state information, including the complete set of Go routines, channels and their wait durations, and my favorite, scheduler information. Backtrace analyzes this state and archives it in a centralized object store, allowing you to explore interesting patterns across your errors and plug rich error data into your resolution workflows. Backtrace is used by companies like Fastly, which is Changelog's bandwidth partner, Limelight Networks, Message Systems, AppNexus, and more. Head to backtrace.io/GoTime to learn more and start your free trial.
So we are back talking to Kavya. So we were just talking about Kubernetes. We were just running a little late, so we had to cut that one short. Did you have any other questions about Kubernetes? Is that something your team is eyeballing, or?
Eyeballing, but right now it's on the wish list because we run all our infrastructure in AWS, and AWS has its own container management and orchestration scheduling service called ECS. So we're quite tied in at this point, but the more I read about Kubernetes, the more I wish it was easy to switch over for sure.
I haven't looked at Amazon's implementation of the container orchestration. But yeah, we typically try to design as much of the software as possible where it doesn't have to be aware that it's run within a container. Kind of like how the secret management works. Like really, it could be Mesosphere or anything else, as long as the secret is handed in through an environment variable, no code has to change.
Yeah, so for our secrets in ECS, well, you basically run a Docker container. So you can pass in environment variables to your Docker container. Other than that, I think you can manage access control on your other resources using Amazon IAM roles. But yeah, I don't think they have anything specifically for secrets, but you can make existing systems work.
In our organization, we too rely on AWS ECS for our image deployments. We do rely on Amazon has the KMS, Key Management Service, which provides will kind of provide you right. They'll provide you sort of a master keys that basically you can rotate them at a regular interval and whatnot. And there's some best practices around that. But what we do is basically that allows us to get those keys, encrypt the secrets, and then basically we ship our containers, our images with a tool internally that is able to sort of make a request to an API to sort of retrieve some data from S3. And that object itself is encrypted using the key from KMS. And then basically at that point, we can decrypt it and get the value and inject it into the environment as the application is booting. So that allows us basically not to have to pass or keys around sort of in the nude, so to speak, and basically just keep it encrypted until it's actually retrieved and sort of decrypted in the environment where it's needed. So that's worked out for us quite well. And it's going back to what you mentioned about Kubernetes. Like I read about Kubernetes and I'm like, oh man, they're doing some really, really cool stuff. And then I'm like, okay, well, we're so tied into AWS right now, trying to bring in, Kubernetes and sort of redo everything we've done. It's just, it's cool, but it's just too costly for us.
I need to look at how that works because I'm interested whether Amazon has some of the newer concepts of Kubernetes, like deployments or cluster federation. So like deployments would be, so you have these primitives like a replica set, and that basically says, so you have a pod, which is a group of containers that move together. And then you have a replica set that says, I need N number of these pods running within the cluster. And then you have a service that you basically expose. It works basically as a load balancer between those things. So a deployment, you can set up these resources that need to be deployed, and it will basically deploy a new replica set with the new version of your containers in it, and then slowly increment the count on that, but decrement the count on the old one for you, and just kind of serve as like this rolling update. And I don't know whether Amazon kind of their container orchestration platform like offers things like this.
Yeah, so on our end, basically, we have Amazon has this concept of sort of task definition, which basically says, okay, for this given container, these are sort of the configuration parameters that we want, right? This is how much memory and CPU and all and resource allocation. When you have sort of a HA environment, this is sort of where I want these things distributed. I want them distributed across different container instances and different availability zones and whatnot. But then it also Amazon also adds a service concept around that basically says, okay, I'm going to create a service, and it's going to be for long-lived tasks, right? Defined by the task definition, and I want to have n number of them, and I'm going to specify sort of a maximum health percentage and a sort of a minimum health percentage. So say, let's take a simple example. If I need at a minimum 2 of this particular container running, I'll say I want a service with a desired count of 2, right? And then what happened, and with a minimum health of say 50%, right? So at that point, what happens is when you have a new container that you want to roll out, what it will do is because of that 50% requirement, it'll spin down one of them, right? Spin up the new container image, right? And then once that other one is up, it'll basically spin down the other one and then replace it by the newer version. So it does have some of that orchestration in place, and you also have the ability to sort of distribute the services on different instances across AZs. So it's kind of working out for us quite well using that scheme.
Oh, that's awesome.
That's what we do as well. But the additional piece that the ECS service doesn't provide is the load balancing. So you would have to, you'd have a load balancer in front of your, like an ALB, an application load balancer in front of your service, for example. And if you set certain parameters on it, it will continue to route traffic to your services. And the way that's managed that Johnny talked about, that side if it works out. So the ECS service will bring down tasks with the new definition. But you have to ensure that you have a load balancer in front of your ECS service.
Yeah, we ended up having to sort of in the beginning roll our own sort of internal load balancer. We had one service whose job was to sort of route traffic to the different services that it was aware of. So we had kind of had our own service discovery behind the scenes, and then internally we had an internal load balancer that basically all the requests went through, and then that service discovery sort of component we then route the traffic to the different services on the boxes that it was aware of. AWS has what they're calling the ALB, or application load balancer, which is different from their classic elastic load balancer. The ALB has the capability, I think, to route the traffic to the different services that it is aware of within your cluster. I haven't played around too much with that, but it does sound like it helps with that aspect of it. Although service discovery is one of those things where there's different ways to do it, and I really like sort of a HashiCorp's. They have a component that actually does that quite well. I'm blanking on the name of it right now, but they have one, and there's actually Linkerd is a very good one as well. So there's lots of options out there, but obviously you kind of find the one that works in your environment.
Cool. Speaking of HashiCorp's tools, because you mentioned Vault and the one that you just mentioned, anybody here play around with Terraform?
I haven't, no.
Okay. It's another HashiCorp tool that is pretty magical. Yeah.
A lot of the HashiCorp tools are magical.
Yeah.
I know. I'm a big fan of those folks. They come out with some really, really cool tools. So for those, Kavya, you want to talk about a little bit about what the tool does for those who don't know?
Oh, sure. So Terraform basically is a tool that helps you manage your infrastructure. So manage and bring up infrastructure. But the cool thing about it is you specify the infrastructure you want as configuration. So it's declarative, and Terraform looks at the state of your existing infrastructure, looks at the configuration you've specified, basically does a diff of it in some way, and figures out what actions to perform to bring your infrastructure up to the state you specified you want it to look like, and it applies those infrastructure changes and it figures out dependencies. So basically, it creates this graph and it figures out dependencies, and so things can happen in parallel, like modifications can happen in parallel. Figures out what dependencies are. So it ends up being a very fast and like easy way to specify changes to your infrastructure. We just started to use Terraform, so I'm a little taken by it right now.
The on AWS Stack, I'm not sure if you played around with that, but the counterpart to that is CloudFormation, which once I sort of discovered, and in the beginning I kind of sort of balked at sort of specifying my architecture, through like JSON and YAML. But once you kind of once you kind of dive in a little bit and sort of look at CloudFormation for what it is, you realize, oh man, like it's hard to go back to sort of a manual or using tools like Chef or Puppet and whatnot to sort of orchestrate that stuff. CloudFormation kind of, once you really understand how it works, it's really a great tool just for that purpose. Right now, it's pretty much my go-to for any sort of stack that I need to stand up. Basically, it's easy to just say, hey, I want the same exact stack in a different availability zone or a different region altogether. And then, basically things just happen magically. It's really awesome to use.
Yeah. Yeah. So Terraform works with, or you can use it with things like Chef and Puppet for the provisioning step. What Terraform does really well is just specifying the infrastructure, like the instances, the load balancers, whatever you want to provide that specification. So how we tend to use it is we do the provisioning off instances, so actually like installing software and all of that separately. But we use Terraform just to bring up the new infrastructure.
Yeah, that's very different from you wouldn't use that as part of your typical development workflow. So it's not like your typical CI/CD pipeline, right? This is more like for standing up your infrastructure that first time, or if you need to reproduce it again, at a later date, or if you need to modify it even, right? So a lot of times you start out with, hey, I know I want a dozen of these EC2 instance classes that, have this sort of, resource configuration for memory and CPU and et cetera, et cetera. And then you realize, oh, I don't need as much as I thought before, or I need more, right? So you can easily change that, basically it's just code, right? Infrastructure is code. So you just commit that and you make, AWS aware of it. And all of a sudden, the state machine kicks in and just says, okay, this is now the desired state, right, for your infrastructure. So if it needs to spins down resources, deletes things that are no longer needed, and it basically brings you to that desired state. So it's a very good tool for setting up the first time and modifying as you go. But basically, obviously, this is sort of a purely infrastructure, not necessarily sort of your traditional development sort of a release pipeline.
Mm-hmm. Yep.
I think we're
changing
geeking out on
subjects.
infrastructure.
Yeah, lots of infrastructure.
Are you guys ready to talk about something else? I wanted to ask Kavya about her interest in firmware. And I think what I want to ask is, you mentioned that you have the interest. So, I mean, it sounded like you haven't necessarily started doing anything, but I was super curious to know, what would you do if you could get your hands on a couple hardware and use Go to do something?
Yeah, gosh. So, so the startup I work at does firmware because there's a hardware engineering team. We make the hardware. There's a firmware team, and the firmware team actually does use Go. So we have sensors, and the sensors are they don't run Go. It's all embedded C. But the gateways, which run Yocto Linux, they run some C++ and some Go. And then the backend's all Go. And I started at this company as, like a back-end system, some infrastructure in that sort of role. But the more I learned about the firmware side of things, I've grown increasingly fascinated with writing firmware code. And it's cool that you can run Go on firmware. So in terms of what I do with that, oh gosh, so
it's all right. So why don't you share? I would love to hear from you. What makes firmware codes interesting to you? I sort of have the opposite reaction whenever I program for hardware, because I worked for 3 years at a company doing just C code mostly C code for hardware. And
Nice.
it's sort of a pain because the hardware breaks or doesn't work like the way you expect. So it's not just the software you're dealing with. We're dealing like this monster. That, like, I'm not an electrical engineer. I have no idea how to deal with this. So that is that. But for me, so I was interested to know what makes firmware code writing for you so cool.
Well, again, with the caveat that I haven't written much, I've only tinkered a little bit. I think the trade-offs is somewhat fascinating. Like the firmware team has to think about like power consumption, which is not something as like a backend or software or traditional software programmer you ever have to think about, right? It's like you need to spin up another instance, you need more memory, you need more like CPU, just spin it up, right? I mean, obviously there's like you optimize your code and all of that, but it's very easy. It's not you're not dealing with hard constraints. Whereas when you're talking about firmware programming or programming on a device, those are all like very real and very hard constraints. And a new constraint that you don't even have to think about is like power consumption. Whereas as a firmware programmer, you're like, oh, in sleep mode, this is how much power my code is drawing, and when it's not sleeping, this is how much power it's drawing. And that's just like the set of constraints you're dealing with is very different. And I think that's what makes it interesting.
So are you interested in writing this firmware in Go or just in general?
In general, but Go sounds like a very convenient way to get started. With things like GoBot and everything else that's coming out now.
Yeah, I think I kind of mirror the thoughts about like the hardware. Like, so I'm not an electrical engineer, but I have piles of parts because I'm slowly learning. But I think the fun part about writing firmware is, one, we write so much code that runs somewhere else. So writing code that like you actually get to interact with physically, and see it turn things or light stuff up, like it's just really gratifying. Um,
Yeah.
and like the thought that you can now invent physical things, not just like programs to run, is really cool.
Yeah.
But I think kind of like that, wanting a deep understanding of how stuff works, I think it's really cool too. Like understanding, like you said, there's odd constraints that come to writing firmware, like actual interrupts and like the amount
Yeah.
of time your interrupt runs for, and how many assembly instructions. Like you can't do like a load modify store, because if an interrupt takes place and modifies that register out from underneath you, like you can munge it, and like
Mhm.
it sounds like a pain in the butt, but I guess the more you build stuff, you want harder problems.
Mhm. Yeah. Um,
So did you
so
come
what
I
up
do
think it
you
might be
with
time for concurrency is hard.
Yeah, the memory constraints are interesting too, though, because especially like if you're working on like say like a normal ARM chip or something like that, depending on what series. I mean, you're working with kilobytes of
Mhm.
RAM, and even if you use a bus, you use like an SPI bus or something to talk to an external RAM, like you're not dealing
Mhm.
with gigs of RAM where you're like, yeah, who cares?
Yeah. Uh,
That's their fault for only having 8 gigs of RAM instead of 32.
yeah, we recently switched to using a different chipset and a different board for the gateways. And the firmware engineers are like, oh my God, we now have like a few hundreds, like maybe like 150 megabytes of RAM available. And it's just like, okay, what are you going to do with that? Uh,
Like, can you blink an LED with that? Like, yeah, in the kind of distributed systems and cloud world and stuff like that. Like when you're thinking megs of RAM, you really are like, what are you gonna do with that?
Boot DM if you can. That's it.
Uh,
Like I'm interested to like understand though, like in the hardware world, like do you have some sort of assurance that if you get it to work on the hardware when you're quote unquote developing, like it'll sort of work every time consistently that same way? Do you have any sort of guarantee as opposed to the software world?
Yeah, so I can probably take this question. I think we should probably take our next sponsor break first, and then I'll come in with this, just because this might be a little bit more. So our second sponsor for today is Datadog.
Hey Gophers, your applications sit on layers of dynamic infrastructure and supporting services, and our friends at Datadog bring you visibility into every part of your infrastructure, plus APM that integrates deeply with Go libraries for monitoring your application's performance, with support for Gin, Gorilla Mux, and gRPC, and more on the way. You can get fine-grained performance metrics from your Golang apps with minimal instrumentation. Datadog integrates seamlessly with all of your apps and systems, from Slack to Amazon Web Services, so you can get visibility in minutes. Head to gotime.fm/Datadog to get started. Get a free t-shirt with full observability, distributed tracing, and customizable visualizations. Datadog is loved and trusted by thousands of enterprises, including Salesforce, PagerDuty, and Zendesk. If you haven't tried them yet at your company or on your side project, go to gotime.fm/Datadog to get started, get a free t-shirt, check them out. Our deepest thanks to them for being a sponsor of the show.
So we are back. So before the break, Johnny, you had asked kind of like almost, you're talking more like a testing scenario?
More like even like running, like once you ship your hardware product, right? Like, are you pretty much guaranteed that, you know, your code, the code that worked while you were testing and developing it, is pretty much gonna perform the same way consistently when it's in the consumer's hands? Like, do you have any such guarantees?
So there's a lot of testing that goes into the physical device and to make sure that everything runs. So usually they do like, there's a couple of test interfaces. So once the board is designed, some people use what's called a bed of nails, which is almost like another thing that comes down and makes contact points onto the physical device. And then it can apply voltage and things like that to different parts of the circuit and then measure other parts of it. And I don't remember the year that this came out, but it's called the Joint Test Action Group, or JTAG, is an interface that a lot of microcontrollers implement. And it basically allows you to communicate with all the chips in almost like a shift register fashion. And you can communicate and apply voltage or read from pins outside of the microcontroller. So you're able to simulate a lot of like unit tests on the actual physical hardware. And then as far as the firmware goes, a lot of things like QMU and things like that, unit tests are written. And then almost in the same way, like we write crash-only software and things like that, a lot of firmware development people have to try to, because you can actually have hard faults, you know, like if you have a stack overflow or something like that, like your microcontroller literally goes into a hard fault state and just like stays there. So there's a lot of things where people will basically trap those, because you get an interrupt when that happens, and you can almost set a callback on that interrupt, and people will reset the microcontroller to try to get it to reboot into a clean state and things like that. So yeah, it's an interesting new world. I don't develop firmware. I know in EE, and like I've had an interest, and I've slowly been learning more things about this. But yeah, it's
you sound like you have a deep interest.
Yeah.
There's like, I'm always torn, because part of me wants to like take just like a single board computer or like an Intel Edison and put Linux and Go on it. But part of me really loves like the assembly and the C and like learning like the guts of it. So I've got like some dev boards that are like literally just like an ARM processor and some RAM. And, you know, I just got one today. I actually thought UPS was going to show up while we were on the podcast. And it has like a 4.3-inch touchscreen on the back of it, and a decent amount of RAM, and a pretty fast Cortex microcontroller. And I'm dying to write some code for that. But that's all going to be C or C++.
Yeah.
Do you think like working on systems with so little resources, but you know, compared to really, really powerful servers that we're deploying stuff on in the cloud. Like, do you think that sort of stuff teaches you to write code that is more performant, or that is sort of a more conservative with regards to resource utilization?
I guess you think about it a lot. I try to be cognizant of that whatever I write, but I guess you try to be more aware of it that way. But usually your compile tools tell you how much space it's going to consume on flash, which is also a problem, right? Like the chip only has so much flash on it for you to actually fit your program in. Like we don't even have to worry about disk storage. Like if you wrote a program so big it fills up your server's hard drive, like you're fired immediately. But so there's things like that, or you have to write like code that pulls more code from external flash. But I think it forces you to be more aware of how the processor works and assembly instructions and the registers and how some of that stuff works, for sure.
So when in the cases where you need to emit data, it sounds like you can have storage that gets shipped with the product, or are you sometimes sort of emitting that stuff over a network? And I know, like, in the world of IoT that we're in, everything's going to have, be able to talk with a network. Like, how would you sort of emit data that you need to sort of collect elsewhere?
Yeah, I mean, most of it for IoT is going to be some sort of, RF based thing, Bluetooth, Wi-Fi, things like that. I mean, you could do a USB interface or an SD card if it's not something, you know. But for debugging purposes, though, a lot of those debug interfaces, you can actually just have like a USB, like a serial connection to your computer that you can kind of push log messages from. Like debugging is probably one of the biggest pains with it. One thing I will say, learning about hardware, if you're not trying to actually design the electrical circuit, like you're just trying to like build a gadget with like Arduino and stuff, it's far more approachable than I think I thought it was. And especially a lot of the chips speak really common serial interfaces. You have SPI, I2C, and UART. And usually all of your chips, like your Wi-Fi chip and your main microcontroller, will just talk over one of those serial connections, or your flash or your RAM will just communicate over that, which makes it really cool to reverse engineer hardware that like you have around your house. Like, oh, there's the microcontroller and there's the flash. What kind of data is it storing on there? So yeah. Yeah, so you can get a lot of chips and wire them together. A lot of times there's Adafruit and SparkFun are probably my favorite places, because you can just order like little breakout boards, and then you only have to like wire up. Yeah, you only have to wire up like the power and the serial lines, and you're like, all right, I'm good. You don't have to worry about all the capacitors and supporting circuitry that are part of that circuit. So, Carlicia, did you get to work with hardware at all, or you just mainly wrote firmware?
I didn't write firmware. I didn't write embedded code. I wrote code that drove machines like printers and laminators, like these huge custom-made machines. And even so, it was a pain sometimes. The machine would turn off and I wouldn't know how to turn it on. Silly things.
There was no power button.
It's just all the interruptions you can have with hardware, like with programming, and then the hardware breaks and you have to stop. I'm like, okay, I don't even know where to start here.
Yeah, supporting circuitry goes wrong and the voltage level drops. Your main voltage coming through across the board, like that should never go below, say, 5 volts, and it does, and it puts your microcontroller in a weird state. And then there's people who do this on purpose. Like there's in the reverse engineering hardware world, there's a thing called glitching. So you can basically set the name for these attributes are escaping me, but there's attributes on the chip where you can basically put it in a read-only mode, which is what you usually do, like when you produce this, so people can't so that people can't read the firmware off of it to like reverse engineer and stuff. And you can set these basically bit flags on there. So you can't get at the firmware to see if there's like hard-coded passwords and things. But people have found ways to like glitch the power at just like the perfect frequency in order to a fuse is what it's called, to basically trip these fuses and then still let you extract the firmware. And it's like, what level of like super geek do you have to be to like understand the physics of making that happen? Like, oh, you know.
That's
I don't
awesome.
know. It sounds like SQL injection to me.
Yeah, I remember the first time I saw a talk about that, and I was like, "You what? You just glitch the power, and like, oh, we're in."
That's awesome.
Yeah, and they'll take heat guns, like FLIR cameras and stuff like that, and they'll X-ray the chips and be able to see like the communication that's happening between individual transistors and stuff. Just yeah, that's a level. I like learning low level stuff. But that's probably a level I will never go to.
I'll stick to the cloud, thanks.
Now, Johnny, Kavya, do either of you do tinker with hardware at home?
Tinker is as far as I've gotten. I've ordered an Adafruit board, an Adafruit board. But when it gets here, I think I'll start playing with it. But I don't have like any awesome projects lined up.
Yeah, it always starts with something silly, and sometimes it's just a
Yeah.
matter of like finding a sensor. Like, one of the first things I ever did was so this was before Arduino got really big. There was a company, they were called Nerd Kits, and a couple people at work had bought one. And basically, if you picture the bare bones components that are on an Arduino board, just an AVR microcontroller, the crystal, resistors, and an LED, they basically just sent you this stuff in a breadboard and like, a long PDF of like how to assemble this thing and run it. And that's kind of where I started out. And one of my first projects was somebody had sent me like a gas sensor or something that supposedly was able to detect also alcohol. I'm like, I'm going to build a breathalyzer. I don't know why, but it just sounded cool at the time. And yeah, you just I'll go through like Adafruit or SparkFun or something and just look through stuff. I'm like, oh, that's cool. Like, I'm going to get an LED matrix to work.
Yeah.
I encourage anybody who hasn't played with hardware just to even start with like a basic Arduino board and one of they're not called hats, a shield, and find a shield to go with it. And you start realizing like it's not as unapproachable as you think it is. And like I said, there's only a couple of common serial protocols that those chips are usually communicating with. So, Brian, who's not on the show today, but him and I have been working on like a controller for our smokers for barbecue, just the PID controller stuff. And, he set up an example with a Raspberry Pi and just talking I2C over the GPIO pin to, some relays and stuff. So it's pretty easy to interface with some of that stuff.
I was so bummed when his talk to actually do a barbecue using his PID controller and stuff, at GopherCon was not accepted. I wonder if the fire marshal had anything to do with that. Like a live barbecue at a conference? Why not?
I don't know whether they ever responded back to us about that, about whether or not we could have barbecue, whether we could bring our own barbecues. Well, I mean, there's still the lightning talk stuff too. The hardest
That's
part
true.
about the talk selection process is the sheer number of submissions we get.
And when we get them, we're talking about the tail end of the deadline here.
Yeah.
I guess I won't tell you when I submitted my talk.
Oh, we know.
So I think we kind of sidelined there on some cloud and hardware.
All the good things.
So, but yeah, I think your talk is going to be pretty fascinating. I think people really are receptive to the how do things work under the covers talks.
Mm-hmm. Yeah, I feel like Go as a like the core contributors of Go also do like a very good job of talking or like explaining, publishing articles of how things work under the hood. There is no content, or I couldn't find any content online about channels already, but the design docs for the scheduler, for example, the garbage collector, even just like the commit messages. They're all like very insightful. It's cool.
I mean, I think that the reason for a lot of that is probably just because like it's a common thing I think I've heard from the Go team when asked about some of the stuff is their implementation details. So I think maybe there's hesitation to put a lot of content out there about how these things are implemented because it could change, in the matter of one release. And maybe they don't maybe it's just a matter of like not wanting to encourage people to develop against the specific implementation.
Mhm.
But I think people also are really interested in just knowing how that works. Plus, like you said, having an understanding of this stuff a lot brings more people to the discussion of like, how does this work? How should it work? And
Mhm.
things like that, rather than it being kind of like a secret organization. It's like, oh, that's the compiler group.
Yeah.
Nobody crosses that barrier.
Yeah. Yeah, and I was going to say it says something about the Go community as well. Every time like one of these design documents is put out, for example, the document's like swarming with people reading it and like commenting on it on Hacker News. So there's clearly like an interest from programmers and like Go programmers to get into the innards of systems, which is nice.
All right. So one of the things we do in each episode, and I'm not sure how much time we have left, but sometimes we'll talk about some of like interesting projects or news for things that we've come across in the past week, or sometimes more if we didn't have time to talk about it in the show before. Is there anything anybody wants to make sure that we mention before we end the show for today?
Gopher.js is pretty cool.
Brian was in love with Gopher.js. I think he's still playing with it on and off, but yeah, he was a big advocate for a while.
Writing JavaScript straight up takes me so much time. But with Gopher.js now, I don't even have to. It's wonderful.
I think I spent so many years writing JavaScript that it's just easier for me to just write JavaScript. I haven't, but I mean, in all fairness, I haven't tried Gopher.js.
Yeah, we're actually considering rewriting large swaths of our JavaScript code in Gopher.js or in Go, so we can use Gopher.js and then run JavaScript.
So here's an interesting question about like the adoption of Gopher.js. How does that typically work? Like, say at your company, because thinking about the way most companies are structured, you usually have like a back end team and a front end team, and the front end team typically controls a lot of the JavaScript. So, is there a barrier to entry for the front end team to pick up Go to learn Gopher.js, or is this mostly just a group of full stack, kind of, as much as I hate using these buzzwords, a bunch of full stack engineers just kind of controlling the whole application?
So the engineering team at Samsara is pretty small. We're like 10 to 12 people. And we certainly have areas of focus. So I'm like on the systems or like the back end team, and there are three of us on that team. But the teams, they're not so much rigidly defined teams as like fluid teams. I don't tend to do a lot of front end, but there are certainly people who do both front end and will do a little bit of back end. And so I feel like most of the people who work on the JavaScript side are familiar with Go and write a lot of Go code as well. So in general, the parts that we want to convert to Go and then use Gopher.js for, I feel like it'll have to be like a slow and a careful transition, like piece by piece. But I feel like the team as a whole is on board with it.
Oh, that's really interesting. It's always been a question of mine for people adopting it. But yeah, I mean, I guess if you're working kind of across the stack, it makes sense. But Go is not that hard to pick up, though, too, I guess I'd argue. Maybe less so than JavaScript. Like, it's easier to pick up than JavaScript.
In my opinion, but that's just me.
Don't start a war.
I have two community-related news to share. One is the videos for GopherCon India 2017 are out. There are about 22 videos. There are some really good presentations there. And also tomorrow, not tomorrow, today actually, in a couple hours, Dave Cheney is going to do a Go remote meetup, and he's going to talk about the hidden pragmas of Go. I don't think I know what pragmas are.
So this is interesting. I just clicked the link. What are pragmas? The
right?
name came from the Pragma Declaration that tells C compilers to alter their interpretation of pieces of code. Now, Go doesn't have a Pragma directive, but it does have ways of altering the operation of the Go compiler via directive syntax hidden in comments.
And that was Eric reading from the description of the meetup.
Yeah, I literally had not heard that this meetup was taking place until you just said something. So I happened to click the link, like, what is this?
Wait, that's today, huh?
Yeah, but it's recorded.
Oh, cool.
So you can also watch it later.
Yeah, so we'll remember to post a link to the recording in the show notes. That way, whoever's listening to this after it's been released can watch the video.
I also saw a mention of Francesca's new Just for Funk episode using context. I watched that. That's actually pretty good. Does a good job of sort of walking through the whys and the hows you'd use sort of the context package to help you sort of handle sort of abrupt termination of client server connections and that kind of stuff. Pretty cool episode. Everybody should go watch that.
Yeah, he gave a talk about context in India as well. So one of those videos for the GopherCon India this year is his talking about the same.
The context package is absolutely amazing, especially for doing like when you kind of have like pipelines in your request, and it's spinning up other Go routines and things like that to just cancel at the front end and just and also the Just for Funk series is awesome. I haven't watched all of them yet, but I've been trying to catch up. But I love the work that Francesca's doing with that. Have you watched any of those, Kavya?
I've watched some of them, but in general, I think Francesca is just like all of the content he puts out is like interesting and accessible. I'm a fan.
We are a fan of Francesca too.
Yeah. So I think we are a bit over time, but one tradition we have for each show is we do something called Free Software Friday. Why it's Friday, I think we just started the name before we released on Thursday. But what we like to do is recognize either contributors to community or open source projects or specific projects that make our lives easier. It does not have to be a Go project. It can be written in any language. If you have somebody in mind, feel free. If not, that's okay too. I'll start with Carlicia and give you time to think about it. If you have one, Kavya. Carlicia, who do you have?
I thought you were saying you were going to give me time to think about it. That will last forever. But I do have one.
I saw your doc. You have somebody there, so you don't need time.
Yeah, I have something ready. I ran into this Go Reporter tool. And I like it because I used to use this a tool that was the same idea when I was doing Ruby and Ruby on Rails. It basically runs analysis tools and testing. It generates a code quality report that you can output to HTML on your browser, and you can see what's going on with your codes. It's pretty neat.
Oh, this is actually really cool. I want to do a comparison too. Have you seen Review Dog?
No, what is that?
It's something similar too, and you can set it up to basically attach itself to GitHub and things like that, and be run on every commit. But it runs some of the same kind of checks. But yeah, I'd like to do a comparison of kind of what the features are.
This Review Dog sounds like a Ruby cop.
I don't think I've seen that. Might have been after I stopped doing Ruby.
I think it's called Ruby Cop. That doesn't sound right, but something cop. Robocop. Yeah. There we go. Sounds like that. Cool. I'll check this out too.
And how about you, Johnny? Do you have anybody?
Yeah, the team over at RoboMongo. So a little while ago, I was needed to sort of quickly verify the schema of some Mongo databases that I was working with and deploying into the cloud, as they say. And then rather than going in the command line, I needed to sort of quickly see everything that was in the different databases. So I went and looked for a GUI tool for Mongo, and there are lots of different options out there, but I found RoboMongo over at robomongo.org to be quite usable and friendly. So it's open source and free. So kudos to the team over there. Yeah, it's a great tool.
I'm looking at the page for it now, and wow, Mongo tools have gotten beautiful. I'm trying to remember the one that I used when we were first doing Mongo, and it looked like normal like Linux GUIs, It's like functional, but not the prettiest. This is actually really good looking.
I was surprised myself.
And how about you, Kavya? Do you have a project or maintainer you want to give a shout out to?
Oh gosh, can I say Gopher.js again?
You can totally say Gopher.js again.
Totally, yes.
So mine is actually kind of suiting to some of our conversations for today. It's a project called GNU ARM Eclipse, and if you play with embedded stuff, almost I swear all electrical engineers are Windows users, because it's very, very hard to find any tools or IDEs that work with stuff for anything other than Windows. Like I have a Windows VM I have to use for specific tools where I set my board on the floor and wire my USB cable, everything. But yeah, so this is actually a really cool project that can do some of the JTAG and OpenOCD for debugging off of ARM development boards and ARM projects. And it interfaces with QEMU for running tests and stuff like that in an emulator. So it's a super cool project, and I'm really thankful for it because I'd have to be completely editing out of a Windows VM all the time without it. All right. So with that, I want to thank everybody for being on the show. Especially thank you to Johnny and Kavya for joining us today.
It was fun.
My pleasure.
Huge thank you to our sponsors, Backtrace and Datadog. Definitely share the show with fellow Go programmers, friends, colleagues. If you aren't subscribed, you can go to gotime.fm to subscribe. Follow us on Twitter at gotimefm. And if you have something you'd like to come on the show and discuss, or just have suggestions for guests or topics, github.com/gotimefm/ping. And with that, goodbye, everybody. We'll see you next week.
Bye.
Be well.
Bye.
All right, that wraps up this episode of Go Time. Tune in live on Thursdays at 3 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time at the changelog.com/community. Follow us on Twitter. We're at GoTimeFM. Special thanks to Backtrace and Datadog for sponsoring this show. Also, thanks to Fastly, our bandwidth partner. Head to fastly.com to learn more. This episode was edited by Jonathan Youngblood, and the theme music for Go Time is produced by Breakmaster Cylinder. We'll see you again next week. Thanks for listening.